Okay, so we've been talked about these measures of center of the curve. Let's talk about measures of spread, of the width of the curve. Probably the easiest way to measure spread is with something called the range. Now for center, we had that mid-range, which involved the min and the max. Well, the range itself also involves the mid and the max. So the range is technically just the maximum minus the minimum. Now, if we look at our data sets up here, it's pretty obvious that the range would be pretty simple. 32 minus 7 is 25. That has a range of 25. This one, the range is kind of meaningless because that huge number, 88 minus 7 would be 81. Well, that's because that 88 is so far away from the rest, that range is not very meaningful. So let's look at some more compact sets of data. Well, let's try this. What is the range of that set of data? What's 23 minus 7 is 16, right? Let's create another set of data. What's the range of that set of data? Still 16. They have the exact same minimum and maximum. They both go from 7 to 23. But would you say they're spread out equally the same? No. This one up here, 14, 15, 16, right in the middle, all grouped together. Down here, the 8 and the 22 are out towards the ends. I would say this one is more spread out. So our range is not really an adequate description of spread. It doesn't distinguish between those two sets. And they're obviously not the same spread, not the same width. So there's something called the standard deviation. Now your textbook gives a really ugly formula for standard deviation. We're going to break it down step by step instead of using the formula. It is a 6-step process. Step 1 is to find the mean of the number. So let's use that first set of data up there. 7 plus 14, excuse me, plus 15, plus 16, plus 23 over 5 gives us a mean of 15. Bless you. So step 1 is to find the mean. Step 2 is to subtract the mean from each number. So I'm going to list out my numbers here. And I'm going to subtract my mean from each of them. So 7 minus 15 is a negative 8. 14 minus 15 is a negative 1. 15 minus 15 is 0. 16 minus 15 is positive 1. 23 minus 15 is 8. Now at this point, I mean, it's not terribly meaningful, but to double check yourself to make sure you're doing things correctly, if I were to add these numbers up, they should add up to 0 every time. If your mean isn't a nice, neat number, you had to round off to so many decimal places with your mean, it might be slightly different from 0, but it should be really close to it. That'd be only because of round off errors. Step 3 then is to square each of those numbers. So negative 8 squared is, now if you punch this in your calculator incorrectly, it's going to try to tell you negative 64. That is not correct. What should it be? Positive 64. Negative 8 times negative 8. A negative times a negative is positive. Notice I put parentheses around it here. When you enter it in your calculator, you should put parentheses around the negative 8 and then the squared outside the parentheses to make sure it's correct. Or just remember it's always going to be positive, and I don't even bother putting in the negative when I square it. I just know it's going to be positive anyway. Negative 1 squared is 1. 0 squared, 0. 1 squared is 1. And 8 squared is 64. That was step 3. Step 4 is to find the sum of those numbers. Sum means add them up, find the total. So 65 plus 1 plus 0 plus 1 plus 65 is 130. Step 5 is a little trickier to describe. Is to divide by n minus 1. For this set of numbers, what is n? How many numbers are in that list? 5, right? So n equals 5. So that means n minus 1 equals 4. So we're going to divide by 4, which is what? 32.5? Is that correct? If we were to stop at this point, 32.5 is something called the variance. If we were doing hypothesis testing and inferential statistics, the variance is an important number. For summarizing data and descriptive statistics, we want to keep going one more step to the standard deviation. Step 6 is to square root. So that's this one. The square root of 32.5 is 5.700. So 5.70 we're going to call it. That's our standard deviation. What the standard deviation is describing is an average distance from the mean for each point. Why did we divide by 4 instead of 5? Well, because the mean itself has no distance from itself. It's right in the middle. It has 0 distance. So if there's 5 numbers, there's only 4 of them that should be drastically different from the mean. Well, we said that this set should be more spread out than this one. So let's, just as a second example, let's find the standard deviation of that set of numbers. Seven, 8, 15, 22, and 23. What is step 1? Find the mean. Go ahead in your notes and calculate the mean of that for me. Did you get 15? Yeah, we add them all up. There's 5 of them there, so we divide by 5. We get 15 is our mean. What's step 2? Subtract the mean from each. So 7 minus 15 is 8. 8 minus 15. 7. 15 minus 15. 0. 22 minus 15 is 7. And 23 minus 15 is 8. What's step 3? Somebody said there's square it. Very good. Square each. Negative 8 squared is 64. Negative 7 squared, 49. 0 squared, 0. 7 squared, 49, and 8 squared, 64. Now, step 4. Find the sum. If we're going to add those together, 228, 226 is what we get. What's step 5? Divide by n minus 1. So n is 5, so n minus 1 would be 4. This is what, 56.5? Which would be the variance, again, if we were asked for the variance. We're asked for the standard deviation, so we need to do step 6, which is square root of 56.5, which is 7.517. We'll round it off. Which is larger than 5.7. So it's showing that that is more spread out. Now you might be sitting there thinking right now, that's a lot of stuff. I'm going to have you guys try one quick. And then we're going to do an example. What do we really use that mean, median, and standard deviation for? How can it be useful to us? So I'm going to give you a few problems here. Or just a few numbers, I should say. Find from these numbers the mean, the median, there is no mode, the range, and the standard deviation. I'll pause this. I'm going to give you, let's take a peek at how you're doing so far. So for the mean, we're going to add them all up. And what are we going to divide by? 6. There are 6 numbers in our list, so we're going to divide by 6, which gives us 16 as the mean. Cool. Anybody have questions on that? Great. Median. How do we find the location of the median? Well, it's n, 0.5 times n. What's n here? 6. 0.5 times 6 is 3. Since it is a whole number, the median is between that one and the next one, between the third and the fourth. So 1, 2, 3, 4, 5, 6. Between the third and the fourth is between 14 and 18. 14 plus 18 divided by 2 is 16. Any questions? All right. The range. Well, 25 minus 7 is 18. And then the tough one. Standard deviation. By the way, from now on, you're most likely going to see me write STDEV, just because I hate writing out the word standard deviation. So we have 7, 11, 14. 18, 21, 25. And we are subtracting our, we've already found our mean, so I kind of skipped that step. The mean is 16, so we're going to subtract 16. 7 minus 16 is 9. Good. 11 minus 16? -5. 14 minus 16? -2. 18 minus 16? 2. 21 minus 16? 5. 5, good. 25 minus 16? 9. Now we square it. -9 squared. 81, -5 squared. 25, -2 squared. 4. 2 squared. 4. 5 squared. 25 and 9 squared. 81. Okay. Next up, add them all up. What is that, 220? So there's some. What are we going to divide by? N is 6, so 6 minus 1 is 5. We divide by 5 gives us 44. And then, square root of 44 is 6.6. Any questions? So the question becomes, why do we care? What good does this mean, median, standard deviation do us? Well, it allows us to evaluate data in a couple of levels. Back to that bell curve. Now, your textbook, I believe, uses something called the exact empirical rule. I'm going to use an approximate empirical rule. I teach statistics, or I've taught statistics for 4 different colleges, and this is the only textbook I've used that's ever used the exact rule. The approximate rule is just so much easier to use because I can actually remember it and memorize it. So the mean is right in the middle of the curve, right? The median, if it's a normal set of data, it should be the mean, median, and mode right in the middle of the curve. But we're going to use the mean. Now, one standard deviation, if I subtract one standard deviation, 34% of the data should be between the mean and that value that is one standard deviation below the mean. Now, since this is symmetrical, what do you think would happen if I go one standard deviation above the mean? Well, also 34%. If I keep going, if I go a second standard deviation below the mean, between 1 and 2 standard deviations below the mean is 13.5% about. Same on the other side. Now I realize it's kind of fuzzy right now. I'll clear it up in a little bit. So another 13.5% there. If I go a third standard deviation below, this is about 2.35%. And this way as well. More then 3 standard deviations below is only about 0.15%. More than 3 standard deviations above is only about 0.15%. Now, right now, that's probably a whole bunch of mumbo jumbo. What does it mean? Well, these percents never, ever change. I mean, they may be rounded a little differently, a little more exact. These are rounded off. But those percents are always the same, no matter what data set we're looking at. If it's normally or approximately normally distributed, those percents are accurate. What changes is the mean and the standard deviation of the data set. So let's say that where you work, the hourly wage of an employee is approximately normally distributed, with a mean of $18.30 an hour and a standard deviation of $2.80 per hour. So it's these numbers down here that are going to get replaced with real numbers rather than just those words. What's going to go right here? The mean, $18.30. One standard deviation less than that means I subtract the standard deviation. So the $18.30 minus $2.80 is $15.50. If I go another standard deviation below, what am I going to do? I'm going to subtract it again. $15.50 minus another $2.80 is $12.70. And how about for the third standard deviation? I subtract it again. From $12.70, subtracting $2.80, I get $9.90. Now I'm going to pause there. Any questions on where those three numbers came from? I started with the mean in the middle, and each step I subtracted the standard deviation of $2.80. Going up, what do you think I'm going to do? I'm going to add the standard deviation. So this is 2110. This will be 2390 and 2670. So, what does that mean? Well, let's say that you wanted to check in to see they're offering you a job. And you wanted to check in and see whether what they're offering you for pay is fairly good or not. They offer you $15.50 per hour. That is right here. You want to know what percent of their employees make more than that. Add up the percents. If I add those all up, it adds up to 84%. So 84% of their employees would be making more than you if you accepted that job at $15.50. Does that make sense? How about you look at, let's say you're already working there and you look at your supervisor who is making $23.90 per hour. You want to know how many people make less than that. Well, $23.90 is right here, right? If you add up all those percents, you're going to get 97.5%. 97.5% of the employees make less than that person. Or he makes more, that person makes more than 97.5% of all the other employees. Does that make sense? So it's a way of us to compare numbers to the rest of the population. We know where we stand. What if they offered us $18.30? Is that a good offer? Depends on your skill level. That means you're right in the middle. Half the people make more, half the people make less. That's average. here's another, let's do another example of this. Pretend that looks like a bell curve. Now let's say you go to buy a home. You're moving and you're going to buy a home, and you do some research and you find the average, the mean selling price. You want to find a 3-bedroom, 2-bathroom house. And you find that the mean selling price of a 3-bedroom, 2-bathroom house in the area you're looking is $140,000. The standard deviation of $30,000. So first thing I'm going to do is I'm going to fill in that table here. I'm putting the percents first because these percents never change. 34%, 34%, 13.5, and 13.5%, 2.35, and 2.35%, and 0.15, and 0.15%. So that part of the curve is always the same. It's the numbers down below that change because of the mean and standard deviation. Where do I start? The mean, right in the middle, 140,000. I'm just going to put down 140 just to save space. If I go to the left, what goes here? 110. The 140 minus the 30, the standard deviation. So 110. What's going to go next? 110 minus another standard deviation of 30 is 80. And the next one is 50. Going the other direction, I'm going to give you a second. Fill in the numbers starting here, going up to the right. So here's going to be 170, 200, and 230. Any questions on where those numbers are coming from? Okay. Let's say that you find a house that you're absolutely in love with. The price of the house is $200,000. Your realtor is telling you, hey, you better put an offer in on this house right now. It's going to be gone before you know it. If you like this house, you better put in an offer right now. Well, the $200,000 is right here. If I were to add up all these percents down here, now I'm going to show you a shortcut, by the way. If I add these 2% up, it's 2.5%. The whole thing has to add up to 100%. So I add those two up, I get 2.5%, and I subtract from 100. Adding these up would have given us 97.5%. What that is telling us is 97.5% of all of the 3-bedroom, 2-bathroom homes in that area are less than $200,000, which is telling me, even though I absolutely love this house, 97.5% of all the houses that I'm interested in are less than that. Chances are I can find a cheaper one somewhere that I still like. Does that make sense? Well, not all. Notice I was very careful to make sure all the numbers fell right on a standard deviation, like 200,000. Not all the numbers are going to, but we can still use them to compare. We use something called a Z-score. A Z-score for a number is taking its value, subtracting the mean for the data set that it comes from, and dividing by the standard deviation. So, for the house we were just looking at, the Z-score for that house, its price was $200,000. Subtracting the mean of $140,000 and dividing by a standard deviation of $30,000. Well, 200 minus 40 is 60,000. Divided by the 30,000 is 2. It's a positive 2, which is important. What that is telling us is the price of this house was 2 standard deviations above the mean, or greater than the mean. Now I look at that and say, okay, that's no better than what we just did with the curve, but it allows us to compare a couple things. Let's say that you're testing to get into school, and you have to take a math test and an English test. And on the math test, you score a 34. On the English test, you score a 38. It's tempting to say, hey, you did better on the English test. But maybe the English test was easier. What's more statistically accurate to do is to compare your score to the other people that took each test. So let's look at the math. Let's say the math score has a mean of 28. A standard deviation of 4. The English test has a mean of 30. And a standard deviation of 5. So let's calculate the Z-score for each. For the math test, what am I going to do for the Z-score? Well, it's the value of 34 minus the mean of 28, and that's going to be divided by 4. 34 minus 28 is 6. Divided by 4 is 1.5. Positive 1.5 means that your math score is 1.5 standard deviations above the mean. How about for English? I'm going to give you guys a second in your notes. Quickly calculate the Z-score for the English test. So we had 38 minus 30 divided by 5. 38 minus 30 is 8. Divided by 5 is 1.6. The English score was 1.6 standard deviations above the mean. So yeah, your English score is slightly better. Make sense? Another more little practical application of this. Let's say you're managing a department store. Let's say you're managing Walmart. What the heck? Everybody has a Walmart near them, right? And you have to fire, you've been told you need to get rid of one of your sales staff, one of your associates. And well, you've narrowed it down to 2 people. You have one of them that works in toys and another one who works in electronics. And you have decided that whoever has the worst sales week next week is the one you're going to get rid of. So your associate that works in toys has a week where they sell $1,200. The associate that works in electronics has a week where they sell $2,800. Does that mean the person from toys is done? No. We need to compare here. All other associates in toys that week had a mean of $2,000 with a standard deviation of $300. All the other associates in electronics had a mean sales of $4,200 that week with a standard deviation of $500. So we do Z-scores. I'm going to have you find the Z-score for both associates, and we'll talk about that in just a minute. So for toys, 1,200 minus 2,000 over 300. 1,200 minus 2,000 is a negative 800. Divided by 300 is a negative 2.67. So that associate was 2.67 standard deviations below the mean. That's what the negative means. For electronics, 2,800 minus 4,200. By 500. 2,800 minus 4,200 is a negative 1,400. Divided by 500 is a negative 2.8. So the negative means below the mean. 2.8 standard deviations below the mean. The associate from electronics had the worst week. And after you fire them, it's going to get even worse. Homework that matches up with what we've discussed this week. In your book, page 321, 1 through 7, the odd. Page 326 through 330. Just kind of a review of graphing a little bit, statistical graphs, 1 through 10. Page 339 through 340 is 1 through 9, the odd. Yeah, I know, it keeps going. 347 through 348. 1 through 9, the odd. 353 through 354. 1 through 7, the odd. 357 through 358. 1 through 6. And I believe it's 359. Yes, the test is going to be all what we did today. The only thing we didn't get covered was percentiles. That will not be on the test. That I think would have been the 363 would have been percentiles, I believe. With that, have a great week. Like I said, please work on corrections this week if you get a chance. Otherwise, we will have a little time after the test on Friday. We can work on them a little bit if you need to. But next week, Friday, is our test, and that is it. We'll have a little bit of review if you need it. And after it, we'll have correction time. Have a great week.